So I think I've done multiple videos on this topic already, but people still seem to love information about this stuff, so we'll roll with it. How about that, huh? Bench is a mess right now. These are the fans off of my truck. It's got a big block in it, a 468. I'm sure if you've ever followed any of my other videos, you've probably seen it before, but we'll talk a little bit about that because it requires quite a bit of cooling. Um, and I've covered this topic so many times already, but we'll talk about this specific instance. This is a Spal fan, Spal branded fan. Spal makes, in my opinion, the best fans out there on the market. They make OEM stuff. You know, most OEM fans are made by this company, anyways. It's an Italian company. I believe Holly bought Spal, or at least they have a stake in the U.S. version of Spal, but these are all still made in Italy. They're very high quality. There's other videos. Maybe I'll post a link up here to fan selection. I've got a video on it. Talks about static pressure and you know different thicknesses, different radiators have different static pressures or resistance to flow, and of course you need a bigger, better fan. So these particular fans are 1777 CFM. Um, they published a performance data on these. You'll see that in that video. These fans at the time were the best that I could get that would fit in my truck. We'll take a peek at it here in a second, and it's torn apart. So we're kind of starting this video in the middle of a project. I'm sorry. It's just the way it worked. I wasn't going to do a video on this, but I ended up doing it. This was the best that I could fit in there for the space that I've got. We run duals. The second one's over there. They were attached to a shroud. The truck has air conditioning. It's a big block. It's got currently has a 2-core, 1.5-inch tube. So two 1.5-inch tube radiator in it. Air conditioning, trans cooler. So there's a bunch of stuff that increases the static pressure. It's probably somewhere around, I don't know, I guess probably about 3/4 of an inch of water column. So that's what, about 20 millimeters of water column. That's quite a bit of pressure to be able to pull through using a fan. And we've talked about this before. The size of the motor has a lot to do with that. DC motors, larger DC motors put out more torque. The other thing that has a lot to do with that is the blade depth. You can see how thin these are, to get the space that you need. So the performance curve on these fans, and I'll show you the other ones when I have them back, and I'll explain why in a minute, why I don't have them right now. I did get them in, but they're at a sheet metal shop. The performance curve on these fans is about 1700 CFM. Like I said, 1777. The new fans that I got are 1800 CFM. Right around the same number, huh? If you try and look up the performance data for anybody else other than Spal, you're not going to find the curve. So we'll insert the data sheets right here, and we'll just keep rolling with this, and I'll have it up in the video here. What you can see is the performance curve for the fans that I'm currently running, or the ones that I just showed you. 1777 and 1800 for the new fan. They're right around the same at zero static pressure. It means free flow. It means this fan right here, free flows with nothing in front of it, 1777. The new fan flows 1800 with nothing in front of it. But if we go all the way down to 20, and let's go back to the sheet here, you'll see at 20 millimeters of water column that we're roughly doubled the flow with the new fan. So that's the thing I'm trying to convey here, is if you look at this performance curve on these two fans, you'll see that the thin fan performs about half as good as the new fan. And that new fan flows 1900 meters cubed per hour, because that's what this data sheet says. Now, we can convert those numbers to CFM. That's relatively easy to do. I can show you how to do that. But my original fan only flows 1,000 at 20. So you see how the curve falls off, right? 0, if we look at the sheet, is 3073 on the new one and 3012. I mean, that's basically, it's very comparable, right, at 0. But look at how it falls off. And as we get to, you know, 28 and, you know, 27.4, that's about as comparable as these are. We're at 0 on the old fan, and we're still at 783 cubic meters an hour. Now, you know, that's a huge performance difference. Now, I've got, like I said, with air conditioning and these fans here, the original fans here, they would keep up on a 100-degree day. They'd keep up. If I was sitting in traffic, they could keep up. The second that you start driving kind of 20, 30 miles an hour where you're not quite getting enough wind in the front, you wouldn't have quite enough capacity. So that's why I just wanted to show you guys. There is, you know, it's very important. Generally speaking, the larger the motor and the thicker the blades, the more pulling power or the more static pressure you can deal with. You can get more flow at higher resistance. So that's a very important thing to look at when you're selecting electric fans. You know, the smaller this motor is, the thinner this blade is, the less CFM it's going to move. And that's why that performance sheet is so important, and Spal publishes it for every model number of fan that they have. So take a look at that, because if you don't, you're going to go, hey, look at this. I found a fan that says 3000 CFM, and it's thinner than the one that's 1700. Well, yeah, at zero static pressure, as soon as you put a one-core radiator in front of it, it's not going to flow anything. So now I'll show you what I'm doing with this under the hood. So now this is my big block truck, and you can just see how tight this is down here. We got the cold case in here now. That's the latest radiator that I've tested out on this. I've tested a few different radiator combinations in this, and we certainly know from other videos that we've done and experimentation that larger tube, fewer tube outperforms, you know, a 4-row, you know, by a long shot. So anyways, the issue that we have here is that the shroud that Cold Case makes, and they won't make you anything else. I think they order it out of China, unfortunately. It centers two fans. It's pre-cut. You can't get it, you know, you can't get it where you can configure it yourself. So I'm having a local shop fab me shroud up for this. It should be done next week. And they're going to have to split them. So instead of having them side by side, we're going to have one low down here and one high up here, because the new fans are about 4.4 inches thick versus the 2.7 I think that the old ones are. So that's all the way to the motor. So worst case scenario is 4.4. So to clear the idler here on the serpentine system, I've got to have that fan down here. And it will clear, no problem. This one, there really wasn't much of a clearance problem over here, but it will clear better if I put the fan up in the corner. So basically, top right driver, you know, lower left. Well, I've got my left and right mixed up. Direction of travel would be lower right. So lower right, upper left is where the two fans will go on that new shroud. And we'll check out the performance of those. I didn't really shoot any video of it, but you know, you can take my word for it. Those two Spals that I've got now were just barely keeping up. You know, it would pick up some temp driving around town, you know, where, you know, it was probably 95 degrees outside with the air conditioning on full blast. As soon as I turned the air conditioning off, it did better. It would cool off. And if you sat at a stoplight long enough, it would actually cool it down. So it is not a radiator capacity issue, because once you get it up about 35, 40 miles an hour, it stays cool. So it's the capacity of fan with light load driving around town. And it wasn't getting hot. I mean, we're talking 197, you know, maybe broke 200. But it's a little bit tight for comfort. I mean, those fans were running full bore. You know, it was in bypass mode for my auto cool controller, which means that, you know, it was running straight from the charging system, basically through a big relay that I've got in there, a big contactor. Actually, it's not really even a relay, it's a contactor. So anyways, we'll get that installed here and we'll check it out. And I'm anticipating that those fans are going to run at about 50% of what the old ones were based on the performance curve. That's what the science says. Unfortunately, it's not real hot anymore. We're starting to cool down. It's getting to be fall around here, and temperatures are mid 70s. Maybe we'll get a hot streak one more time before Halloween. That's usually what happens, and we can take it out on a hot day. But this is definitely the way to go. We'll show you those new fans as soon as they come back. The guy that's fabbing the shroud for me needed the fans, obviously, to mock it all up. So we'll get back to it. All right, so it's been a little bit of time. Got the shroud from Rich Sheet Metal Works, my local guy. Excellent shop if you're in the LA area. He's in Santa Monica, which is kind of unusual to find a place like this. But anyways, he went and fabbed this up for me based on the one that was on it. But obviously you can see we got the staggered fans going on, so we got some clearance now. This gives me clearance for the pulley that's right here. It gives me a little bit more clearance from the power steering pump that's right here. So that's all good. These are the fans that I was talking about. I just think I showed the data sheet on it, or I'm going to insert it or something. You see how much deeper these are and how much thicker the blades are? That's where you get your efficiency. That's how you get more pulling power and more vacuum with more resistance by having a much bigger blade and more torque. This motor is larger than this motor. So anyways, I've just got to get these mounted up. Now I'm thinking he put the holes in there for me, which I was hoping I'd be able to use nuts and bolts, but I can't get the shroud in there with the fans on it. So I think I'm going to have to put riv nuts in here, which is fine. I got a riv nut gun. We'll bore these out and put riv nuts in it, and then I can put the shroud in and I can put the fans in. That'll actually be kind of nice because then I can replace the fans with the shroud in there if I ever need to. Just a little Loctite on the riv nuts that does those real good. So let me get this in there and let's see how it fits up. Okay, so we test fitted against the radiator, no problem there, and I went ahead and bored these holes out and put riv nuts in. If you're not familiar with these, they're a very handy tool. I'm sure as soon as you see these you go, that's what those are. So you can see how they're riveted in here. And I have a special tool for that. It's a riv nut gun. You can pick these up at McMaster Car if you want a good one. They make a hydraulic one. Doing these 8 was about as much as my hand could handle. But if you're going to do them every day, they make a hydraulic one. And the only thing you got to be careful with these is that they do sometimes when you crimp them, sometimes they have a tendency to kind of go a little bit off center. So when you're talking about something like this where it's a fixed pattern on the fan, that could be a little bit challenging. And we'll see if I have to enlarge the holes in the fan a little bit just to get some fudge factor in there. But it'll probably be all right. So but you see they make it really nice, so you can replace the fan, but you have no nylock on here now. So we have to put Loctite on these because the vibration will make them come loose if we don't do that. As the Three Stooges would say, a perfect 36. So I didn't have to do anything. I can barely get the washers in here with the way that these are set up. They're probably designed for a smaller washer, but whatever. They're metric, so it doesn't fit quite right. But they do. The washers do fit. They do clear. There's a little step in here if you can see it. See. So, anyways, we're good. I can put the fans in the truck with the problem is I can't put it in with the fans and this because this has to kind of go over the radiator and kind of go over the core and then set back in. It's not going to do that. There's not enough room to do that. But with the shroud in and then dropping the fans in separately, it will clear. So I have to be able to take those fans off with the shroud in the car. Definitely measured it just right. We got just enough clearance, and I've cheated the radiator forward about as far as I can get it. So that one obviously no problem there. But yeah, we got some tight clearances going on with this bad boy. So let's see what we got here. I just tossed the clamp meter on there. Let's get that zeroed out just to get an idea where we're at. And I'm just going to hook up the bypass relay right now. I got my clip lead on my bypass relay that I've got. It does have the PWM controller still. Let's see what we got. So 33 amps for both right now, and now that's at 12 volts, so it's going to be a little bit low. That's a good sign. That means that we're pretty efficient right now. Now, when I say efficient, that means that we don't have too much static pressure. The current will go down the less static pressure you have because it needs less torque. Torque is current. So the only thing that's left now is, to finish putting this back together, and luckily we got one more hot day coming up here, I think tomorrow or Thursday. So we're going to give it a trial run when it's hot. So this is full voltage, or full, running. So we have, a good solid 14 volts to it. We're pulling close to 47 amps. That's about right. And these suckers move air, and I mean they move it. So, it's getting towards the end of the season, into fall, when I have to shoot at night. So anyways, it was a little hard to talk over everything, when it's running. So if you couldn't hear it before, we're running about 47 amps at about 14.5 volts. I was thinking about the numbers from last night, and it wasn't calculating to me. We were reading like 33 amps or something like that, and that didn't sound right against the charts. So I emailed my contact at Spal. He's an application engineer, super sharp guy, and I told him what I was seeing, and he said they test him at 13 volts, which I knew, and I knew I was below that a little bit with the battery, in the 12.5 range. He said we tested at 13, but we tested at the terminals. And he said on top of that, he gave me an updated data sheet for these fans, and they're coming in at about 19 amps free flow at 13 volts. So we're right on par there, because as the static pressure goes up, the current goes up, right? It's just more load, more current. It's just like more load, more torque, more load, more horsepower, right? Same thing. So the current draw, we're looking at, what did I say? It was about 47 amps or so. So what's that? 23.5 each. That's about right. 23.5 amps a piece is about right. It should be somewhere between 23 and 25 with this much static pressure. I was assuming somewhere around 3/4 of an inch of water column static pressure based on the thickness of the radiator, AC condenser, transcooler, etc. So we're right on par. So yeah, you're looking at about 50 amps in fans here, to be conservative. But these things do move a lot of air. Something interesting too, I just ran it and I got it hot, and ran it with the AC running, and now with the fans running at a slower speed just to cool the radiator, they're not, I have a trinary switch on this, so I don't use the AC compressor to turn the fans on. I don't tell the controller to step up the fan speed using the compressor, because that's actually not the right way to do it. It's pressure-based. So the trinary switch is a preset pressure, where if the pressure gets high enough, it tells the fans to turn on, so it cools the Freon more. And that function's not kicking in. The regular cooling of the fans is enough, even at a low speed. It's enough flow to keep the pressure low enough in the AC system where it actually doesn't need to kick the fan speed up. So I found that really interesting. That's one clue that it's moving more air, because I really don't have a way of measuring it. I'm only going off of the engineering purely. It's really open loop. So I'm sure that these fans move much more air. I think just by feeling it with my hand, I can tell they're moving a lot of air when they're running at a much lower speed. So probably not going to have another hot day. I didn't get a chance to drive it today. I'm just too busy with other things. But it definitely big improvement. You can see how tight things are. I think I might have showed that already, but it's asses and elbows in here, that's for sure, especially with this fan. Over here we got plenty of room. So anyways, I think that we'll probably wrap this up. One of the things that I didn't have Dave do over at Rich Sheet Metal was put flaps in it. I want to see how it performs without it. I think there's probably enough outlet area with the two fans where I don't need to do that. But if it heats on the highway at speed, that's how we know that we're not getting enough airflow through it. We may have to add some flaps, but we can always do that later. So, get the biggest freaking fans you can in, especially when you're making horsepower and you got a lot of cubes to cool. These came out in 2020. The fans that I had spec'd for it at the time were the best available, and what I could fit in here. It'd be great if I could put two 16-inch fans in here, but just this core is just not that big. So when these came out, and I was talking to my buddy John, who's got a Mustang, and we were dealing with some cooling issues with him, and I helped him out by speccing some fans. We found a little bit smaller version of this one that we used on his Mustang. And when I stumbled across these are the best, highest performing fan that Spal makes in a 12-inch diameter. So, you can just tell just by the thickness. That thickness of that blade is what gives you performance with resistance. So we've talked about this 10,000 times. We take a look at the engineering here. When I help people with cooling systems, we don't go off of, we just put a 2000 CFM fan on there. We look at, what do we got in front of it? How much resistance is there? How much space do we have? What's the best performance curve that we can get for this? And, it's just one of those things that I'm all about. So anyways, it's just kind of a good one for people to see and understand. So we'll wrap it up.